Hey guys, today is lesson 1.2, graphs of functions. So remember, the vertical line test will identify whether or not something is a function. You're not allowed to have overlapping points. So it can either be a function or a relation. A relation, remember, is just a set of ordered pairs, and a function passes that vertical line test. Okay, so let's talk about each one. The first one is a function. Passes the vertical line test. The second one, also a function, also passing the vertical line test. This one, you can see right here and here that they do overlap, so it does not pass the vertical line test, but this is at least a relation. There are a bunch of ordered pairs in there. And then same with the circle, a relation. Okay. So our intercepts, x-intercepts and y-intercepts. X-intercepts, y equals 0. Y-intercepts, x equals 0. Okay. So to find them, we have two methods, one with a graph and one algebraically. So the first one with the graph, our x-intercepts cross the x-axis. So my x-intercepts are at -3, 0, 1, 0, and 4, 0. Where my y-intercept crosses the y-axis at 0, -3. It's easy to identify them on a graph, okay? Now let's talk about it algebraically. To find the x-intercept, we need to set this equal to 0. So 0 equals x cubed minus 3x squared minus 4x plus 12. 0 factor solved, so factoring it by grouping because there are 4 terms. 0 equals, GCF of this is x squared, so bring that out. X minus 3, GCF, -4, x minus 3. Remember, if what is inside is not the same, you've done it wrong. So my first factor is x squared minus 4. My second factor, x minus 3. We can keep going with this one. It's a difference of squares. So x plus 2, x minus 2, x minus 3. Okay. Now that we have that, we can solve this. X plus 2 equals 0, x equals -2, x minus 2 equals 0, x equals 2, and x minus 3 equals 0, x equals 3. So my x-intercepts are -2, 0, 2, 0, 3, 0. Okay. To find the y-intercept, we set x equal to 0. So f of 0 is what we're doing. 0 cubed minus 3 times 0 squared minus 4 times 0 plus 12. Well, that all goes to 0. So f of 0 is 12. So my y-intercept is 0, 12. Okay? Okay. In general terms, we can say that a function increases over an open interval of its domain, of its graph, when it rises from the left to the right on an interval. And it decreases when it falls from the left to the right. And it's constant if it stays at a horizontal. So we are going to talk about increasing, decreasing, and constant. Okay? So we have increasing. Increasing starts here and stops at its peak, and then it picks back up from here to here. It is an open interval, so that means we only use parentheses on increasing and decreasing. So And we use the x values. So it's increasing from -8, let me use green, -8 to -4, and then also 3 to 6. Okay, decreasing in red. So we start going down the hill there. So this would be -4 to -2. And then constant here in the middle because it's not going up or down. So -2 to 3. Okay. There we go. Now, those are increasing, decreasing, and constants. Talking about domain. Domain is left to right. It is closed circles, so closed brackets, from -8 to 6. Range is from bottom to top, so -4 to 8. Also closed brackets because it's closed circles. Okay, what thoughts do you have about the intervals stated above? Do you use brackets or parentheses? Why or why not? Okay, we're going to use closed brackets for domain and range. And included points, meaning they're closed circles. Okay, so that's closed brackets. We use parentheses for intervals increasing, decreasing, constants, and open points that are not included, meaning open circles. Okay. Perfect. So using Desmos or your calculator, go ahead, pause the video, and plug in to your Desmos the graph. Okay, you should have said it is increasing from -infinity to 0 and 2 to infinity. It's decreasing from 0 to 2, and there are no constants, so none. Same thing in your Desmos. Type this into and find increasing, decreasing, constant. Increasing from 1 to infinity. Decreasing from -infinity to -2. Constant from -2 to 1. Okay, within a graph, we also have our extrema, which are our local and absolute max and min. Okay, so okay, we're gonna label this. Here we go. I'm gonna start with B. B is our absolute min. Minimum. It is the lowest point in our graph. We will never go lower than that point. Okay. D is a local maximum. You might also hear the word relative maximum or relative minimum. Local and relative both mean the same thing. You can interchange those. That is a local max or a relative max because it's not our highest point, but it is a peak in our graph. F would also be considered a local or relative minimum because it is a low pit in the graph, but not our lowest one, because B was our lowest one. C and E are known as points of inflection. A point of inflection is a turn in the graph. We are increasing and then we start to turn. So it's a point of inflection, meaning it's a point where the graph starts to change. Okay. G would be our absolute max. And A would be a local or relative max. Okay. G is higher than A, so that's why it's considered absolute. And A is still a high point on our graph, just not the highest point, which is why it's a local or relative max. Okay. So a local maximum is what I just described, which can also be called relative. That's what I was telling you. Okay, so a relative maximum is here. We have a max. Okay, it's at the height of 1 unit when x is 2. If I'm asking for the relative max, it's the height of the point. So it's always going to be your y value in the coordinate. It's not the ordered pair. The relative min is at 4, 0. So it's at 0 when x is 4. And then another relative min is here, -8 when x is -3. This would also be our absolute min. Okay. Okay. Approximating extrema. So in Desmos, you're going to type in this equation, okay, into your graph. And you're going to hover over that peak, okay, or click on it. The ordered pair should show up. -1.15, comma 4.08. Make sure that's what you get when you click on the max there. And then your min, if you also click on it, should say 1.15, comma -2.08. We're just rounding to the hundredths. It will probably give you more decimal places. Okay, so our local max, and it's a local because this graph continues up forever and continues down forever. So they're not absolute because the graph continues higher than that actual maximum, okay? So it's at 4.08. That is the height. Where it occurs is the x value, -1.15. The local min is at -2.08. That is the height, and it occurs at 1.15. Okay, so this is our extrema. Now let's talk about boundedness. Bounded is how the graph is expanding, like whether it stops or keeps going, bounded occurs. So if it's bounded, we have a top bound here and a bottom bound. There are points at which the graph will never go higher or lower. So this one would be the upper bound, and this is the lower bound. And so this graph is bounded because it never goes above or below a certain point. This one is bounded below because the graph continues up forever. So our lower bound is there. This one is bounded above because we're never going to go above that certain point. So this is our upper bound. And this is not bounded because the graphs go on forever in all directions, never reaching a max or a minimum. Okay. Continuing on to symmetry. So, why is it? There we go. Okay, sorry. Even functions are when you plug in negative x and you get out the original point. Okay? So they stay the same. Where odd functions is when everything goes opposite. Okay, so if it's even, when you plug in negative x, everything stays the same. And when it's odd, everything is the opposite. Okay, so looking at this, if we pick 2 points up here and here, okay, 1, -3, and then it's at 1, 3. So it went opposite, which makes this odd, and when it's odd, it is always a origin symmetry. Okay, so you would state odd, origin symmetry. When we have a question like this, okay, so 4, -3, -4, -4, -3. Okay, our x's stayed the same. Oops, I erased too much. Okay, our x's stay the same, so this is an even function, and when it's even, it is a y-axis symmetry. So again, you would tell me even and y-axis symmetry. The last one is at 1, 1, 1, -1, and 3, 1. So none of this is the same, so it is neither. Which means it's neither even or odd, and it's no symmetry. Okay? So let's practice this algebraically now. Okay? We replace x with negative x. So it becomes f of negative x equals the absolute value of negative x minus 2. Now, remember, a negative and an absolute value is always a positive. So this simplifies to a positive x minus 2. Now, everything when you look at this is the exact same. So this tells me it is even, which is a y-axis symmetry. Okay? Now we look at b. So again, f of negative x equals negative x cubed minus 3. Simplify that. We get negative x cubed minus 3. Now, the x cubes are opposites of each other, but the negative 3's are not. They're the exact same. So because of this, this is neither. Okay, remember, it either all needs to change and become opposite, or it all needs to stay the same. Okay. Okay, so because only part of it changed, it is neither. Last one, f of negative x equals 2 to the negative x cubed minus negative x. Okay, simplify it. Negative x cubed is negative x cubed, so negative 2x cubed, and double negative makes a positive, so plus x. When you look at this, everything is opposite, a positive to a negative to a positive. So they all went opposite, which makes it odd. Think opposite odd, and when it is odd, it is an origin symmetry. Okay, we are done with these notes. We are not going to do the last piece on concavity, so you don't need to worry about it. Have a great day.